All right. Hello, everyone. Good afternoon. Good morning. No, it's good afternoon. Good afternoon. Happy Friday. It's the end of the week. Thank you for logging in on a Friday afternoon. It's all very exciting. We're going to be doing some pretty exciting things today. Don't worry, we will recap the 2D array that we were doing last time. We'll go through it. We'll draw some stuff. Today with me I have the other Tom, not Tommy. Just Tom. Tommy is not feeling well, so Tommy is at home resting, keeping his doggies company. And we have Tammy, of course. So now there's Tom and Tammy, but not Tommy. So, and Tom, you didn't realize, but we've started calling the other Tom Tommy to avoid confusion with you.
This makes my life so much easier.
Yeah. I'm not sure he likes it, but his name is now Tommy for the time being, for this term. So I hope everyone is doing well. Everyone is feeling okay about week 4. Everyone is, chilled out after that music and ready to take on this lovely lecture. Again, I don't know why I've just called it a lovely lecture. It's not going to be that lovely. It's going to be amazing. Okay, welcome to lecture 8. We are in week 4. We are ready to... we're ready to go. So last lecture, we went back, we reinforced one-dimensional arrays today, and then we looked at two-dimensional arrays. So we made a grid, we did some pretty cool stuff maybe, and then today we're going to go back to that 2D array, and we're going to look at it again. We're going to look at this question again, we're going to draw it up. I drew up a grid in the lecture notes, so you don't have to put up with my terrible grid that kind of has lines all over the shop, diagonals, because that's not what it really looks like. So I've got like a whole background for my grid today, and then this is the moment that everyone really starts loving 1511. We're going to introduce you to pointers, and honestly, this is probably I can't do this anymore. No. Everyone loves pointers. Let's leave it at that. No. Usually people find pointers okay when you explain them first. So I just want to give you background. And then when you go and use them, you just think, what is this thing? So do not worry. The best way to get to know pointers is to use them a lot and to make a lot of mistakes with them as well, because you'll see some pretty fun stuff happening, or not so much fun stuff. You'll see some good stuff going on. Oh, Tom's just humble bragging. He loves pointers. Here we go. All right, where is the code? Tom, could you please post the link for the code in the chat? Thank you so much. Someone's asked, was there a live stream for assignment 1? Indeed, there was. It was a live stream. And it was on Wednesday, and we had it is recorded. It is available to you, so please go back and have a look at it. It was a few days ago at 3:00. That's right. All right, so that's today's lecture code. That's also where we have our other lecture code from Tuesday as well. It's just the whole week, so there we go. So let's have a quick recap. Okay, and also because I had a typo in my other slide, which I kind of corrected, but I'm not sure if I did fix the lectures and put the new slides up as well. And it was in accessing the array, the two-dimensional array. So for example, let's say we declare an array of arrays. So int array 3, 4. Remember that the first number is the rows, and the second number is the size of the columns. So that means there's going to be 3 rows. And remember, we start indexing at 0. So row 0, row 1, and row 2. And we have 4 columns. And it's column 0, column 1, column 2, and column 3. Actually, also, Tom, could you please put the Slido in there as well to keep track of the pace of the lecture? So please feel free to let me know if I'm going too fast, too slow, or just right. And then I'll pace it based on that. Okay, so visually, if you draw up that array, and if you were to, draw some diagrams when you're helping yourself solve some questions, what it will look like is something like this. You've got a rectangle, it's got 3 rows, it's got 4 columns. And then to access each one of them, you basically have the name of the array, and then the first square bracket is your row number, and the second square bracket is your column number. So I've kind of gone through and labeled all of them just to give you an indication of what it's going to be. But it's easy tell if you draw it up, and if you do your column 0, and if you do, row 0, column 0, then that's how you're going to access this, this array element. Okay, so let's recap. Let's go through our question that we had before. Let's go through the code, and that's how we're going to play around with it. So I'm going to go through the code and we're going to draw it up. So I'm going to move some things in a very funky way so you can see both here, and then we're going to talk about it a little bit more. All right, and I'm going to grab my pen. We didn't calibrate it. We forgot to calibrate it, so I hope that it's still in the right place at the right time. So let's go through this code and see if everyone understands it, because that was the feedback that people kind of lost me a little bit during this particular piece of code. Okay, thank you. The grid is so much better, right? Amazing. Okay, so we have a hash define here for the number of rows, 10, and a hash define for the number of columns, 10. So what we have here then is we have 10 rows, and remember indexing starts at 0, that means it goes to 9, and then 10 columns, so it starts at 0 and it goes up to 9. I feel like we're about to play battleships, but no one's gonna, no, maybe. So then we define a struct for player to hold 3 things, okay? We've got 3 things. We've got a character name, so we've got a character that is the name of the player, and we've got a position row and a position column. So there is a coordinate for where you are at. Okay, great. Then we've said, okay, we've got a helper function in here. This helper function prints out the section map as a 2-dimensional grid, and we'll go back to it in a second. So let's have a look now at what we have inside our main. Okay, so the first thing we did is we said, okay, we have an array called a 2-dimensional array because it's got 2 square brackets. It's called section. It's made up of ints, okay? And this section has 10 rows and 10 columns. And then I've initialized that array to have every element be 0. So on line 42, we've declared and initialized an array. And what it looks like is that as we've done that, it's going to create this array and it's going to give everything a 0 in here. I said this last time, and I really should have just done a much smaller version for this example. But here we are. I've committed to this diagram. I've committed to drawing it so that everyone understands what they're doing, because I think if you draw it like this for your assignment, I think it will be really, really helpful. Isn't this fun watching me draw zeros? Oh my goodness. They're getting more and more obtuse. Can a 0 be obtuse or only an angle? Should see the look on Tom's face when I asked that. It was a rhetorical question. Any day now, any day, getting there. Here we go.
3, 2, 1, 0.
Blast off. All right. Yeah. Okay. Watching paint dry. Yeah. Something like that. Okay. Fantastic. Great. Okay. So that's line 42. Then what we've done is we've declared a struct player. So there is a variable that is struct player, and the name of the variable is Sasha. So that means that Sasha, the variable name, has 3 things that go with Sasha. It has a char name, an int position row, and an int position column. And here we are initializing, okay, here we are initializing what on earth Sasha is going to have. So line 46, the character is going to be S, the position row is going to be 9, and the position column is going to be 9, which means that Sasha is going to be standing at 9, 9, which is over here. Okay, so then I print out the row, and if we go down to the calling of the function, because that's what that line did, we go down to our helper function that prints it out. And I'll explain the EOF loop, don't worry. Yep, I will, absolutely. Good thinking. Tom, could you please pop that on the board so I don't forget? Thank you, Tom. Okay, so then I start to do my int row while row is less than 10 in column, whilst column is less than number of columns. Yeah, so I'm saying by default it's at 99. Okay, now the only thing we had to do in this function is we needed to print out the character for the player when it's where they're currently standing. So what I really want to do is, as it's going through, when it's equal to 99 or whatever the position row and the column row in where I'm standing is, I want it to print out an S instead of a 0. So I'm going to check whether the coordinates of where it is up to when it's doing a while inside a while, I'm going to check that the row number is equal to whatever is inside my position row, and the column number is whatever's in my position column. So if those two are equal, so for example, this one here is 9, if the row is equal to 9, and this here is 9 as well, if the column is equal to 9, then I'm going to print a character for my name. Otherwise, I'm just going to print a 0, which is what was inside this array. Okay, so what that means is now I have, instead of having this 0 here, I'm going to have an S sitting inside here. Okay. So that puts an S in there. All right, fantastic. Otherwise, it's going to print a 0. Done. Okay, then I move my column, then I move it back down, and then I'm going to increase the row as well. Okay, great. So I finished this function here, which means that I return to the place where it was called from. So I'm going to head up here, and I'm going to return to over here because that's where I called the function from. Great. Okay, I've now returned here. So now I want to scan in a command because I want to know where it is I need to move. Do I need to move left, right, up, or down? And I've got the symbols for all of those going on. Okay, great. So I need to scan that command into something. So I've got a character called with a variable named direction, and that's where I'm going to scan in that character into. I've asked where would I like to go and told user what their options are, and then wait for them to take an input. Okay, then I am going to do this EOF business here. So let's explain this EOF again, okay, because yep, excellent. Okay, so what on earth does this line mean? Okay, now if you remember when we had something, and I'll just put it down here in a note so it's not just me talking, but you have something to remember what I'm saying. So if we had scanf, okay, and we had a %d, and let's say I had and number, okay. If I entered in a number and it scanned it in correctly, this would return 1 to us, wouldn't it? Yep. Okay. If I had scanf %d and number and typed in a char, it would return 0. Okay, so there is a special thing that scanf can return. So scanf can return the number of things that were scanned in and placed into variables, but also it can do one more special thing. Okay, it can return something called an EOF. Okay, so EOF is just a hash define inside one of the standard libraries that you're taking. So inside that stdio.h, there is a hash define EOF, and then it's equal to something. Okay, so it's not just like this random, it just means end of file, you've got end of input, that's it. So what it's saying is it's got an end of input. And that end of input is basically the way to simulate it is to press Control plus D. So when you press Control plus D, what it returns to scanf, it returns something else, not 1, not 0, it returns an EOF. And you're waiting to catch that EOF. So when something is not equal to EOF, you want to keep taking the inputs. But when something is equal to EOF, that means that you've pressed Control D and you want to stop taking the inputs. So that's why this while loop is scanning in whilst it's not equal to an end of file. Okay, so you're going to keep scanning in until it's not equal to an EOF. So then I'm saying, what would happen if there were 2 inputs? It doesn't matter, because I can return, even if I have %d, that would return, and number, and maybe I'll have and number 2. this would return 2. So it would always be a positive number of things that I might return. Or if nothing has been scanned in, it will return a 0. Okay, and EOF is usually something different, like a -1, right? Okay, so someone's asked a great question. Is there any difference with replacing EOF with -1? Okay, the reason we use EOF and not writing -1 is because it might not necessarily always be -1. Okay, so if you go on, you learn other things, you learn other languages, the EOF is always there kind of thing, but the -1 might not always carry across. So you really want to use the correct term for it, which is the EOF. And it's much easier to remember that than remembering, oh, maybe this returns a -1 and that's what gives an EOF. So it's much easier to say that EOF is something else, okay? And it means something else. So you're checking for the EOF instead of just checking for a -1, because other things can potentially lead to an EOF as well. So it's like you're saying stop. Yeah, okay. So I think, anyway, Tom will place whatever I need to answer on the board. And someone's asked, okay, no, Tom's answering them. Yeah. EOF stands for end of file. So, but again, I mean, I think actually maybe it's helpful to know what it stands for, because then it makes it really easy. Okay, so someone has said, what if it's equal to 1? Yeah, okay, so how is it different than saying, please scan it until it's equal to 1? Yeah, I mean, it's a good question. Okay, it's a really good question, because you can do it and it will really perform the same thing, right? Because if it doesn't scan in anything, then it will just return, but what happens if it returns 0, okay? And what happens so the reason we don't do equals to 1, okay, let's talk style to start with as well, but also remember how we don't want to have these random numbers that just appear out of nowhere that we're using, because when someone is reading your code, when you're checking that it's returning 1, it's not as obvious what's going on. They really need to focus. When you tell me that you're reading until EOF, I know exactly what you're doing. I know exactly what you need to do, okay? And if you have 2 arguments, 3 arguments, 4 arguments, okay? So like here, I've returned 2 maybe, but what if I gave 1 number and 1 character? Then I would have returned 1, but really that's not potentially incorrect, depending what the context is. So when you're checking for EOF, you are literally checking, has everything gone okay, or should I finish right now? So it's kind of checking for a whole bunch of things, and it's also stylistically a more correct way to check for issues, for end of files, okay? So finish the input at all, full stop. So you don't need to declare the EOF. The EOF is living inside this stdio.h. If you open up that library, it is in there. It's going to have a hash define EOF and a whole bunch of other things, and it's going to define all of those types of things. So you just use it, right? You just use EOF. You don't have to do anything to use it. It's just free for use. And it's much neater as well. Okay. How's everyone feeling about that? Jax asked, what if you have a variable equals scanf's return within a while loop and have that variable be the condition of the while loop? You need to clarify that for me. Write a piece of... Oh, Tammy's answering it. Okay, great. Even better. Yeah. All right. Excellent. And Jeffrey, so when you input a number and a letter to scanf %d%c blah blah, it would return EOF. Not there, because you've just %d%c and you input a number and a letter. You're scanning in proper things if you had an ampersands in front of your blahs. So it wouldn't return an EOF. EOF is returned when you press Control D. So that would continue working if you're looking for an end of file. Yeah. Okay. Yeah. So EF is Control D, which is a nice way to finish it all up. All right, so here we've done that loop that basically keeps taking things in. It keeps taking things in until that Control D is pressed. So we're going to keep doing this until we see a Control D. All right, then what are we going to do? So remember in our problem we said, actually, I want to know where I've already been so that I don't go there again for the second time. Which is why instead of these zeros, if we move somewhere, we then want to change that location to have a number 1 in there. It doesn't matter. It could be anything else. Okay, just number 1 and number 0 were the easiest numbers to come up with. Okay, so what I'm saying here is this array at position row where I am and position column where I am is going to be equal to 1. Okay, so what that means is inside here is now going to be a 1 when I move off it. Okay. So when I print the map again, I've said I really want to have, oh God, that's not where it's meant to be. I want that to be, that's not really helping either. So what it's going to do is instead of having that printing out that S there, it's going to print out a 1 here, okay? But it's not printing yet, okay? All right, and now I'm going to check for my conditions. All right, let's check for my conditions. If you inputted a left thing, then if you remember we drew up, so if I'm going to move to the left, if I'm standing over here, so if I'm standing over here and I'm moving to the left, my column is going to get less because I'm going to move from column 9 to column 8. Yep, so I'm going to move, and the only thing that's going to change, my row's the same, but my column is going to decrement by 1. If I move to the right, then my column is going to increment by 1 because I move this way. So my row will stay the same, but my column will increment by 1. Now, if I go up, then so if I move up here, my row gets less, but my column stays the same. So then I decrement by 1. And if I move down, then my row increases because I'm going, down this way. But my column stays the same because I'm still in the same place going down. So then my row increases. Excellent. Okay, we've said that works really well, so that moves me around the place. But what happens if I try to walk off the map? And we kind of simulated that situation in the lecture on Tuesday. So what happens if I walk beyond the boundary? So I'm standing over here and I say go down, and then I come off the map. So I want to stop that situation from happening, okay? So I'm going to check whether or not the movement will force me into a boundary. And I can do that because here I've already increased or decreased the rows and columns. So I can check if that is, beyond 9, or if it's more than 9, or if I'm standing here, if it's less than 0, or if I'm standing here that it's less than 0. So the boundaries can occur in a few situations. It can occur if I'm standing over here, well, in this whole row, because that means if I go up, I'll go out of this loop. And if I'm standing in this row here, in row 9, if I go down, I'll disappear off the board. Or if I stand in column 0 and I go to the left, then I'm going to disappear off the board. And if I'm standing in column 9 and I move to the right, then I'm going to disappear off the column as well. Okay, and someone's asked, what is the function of the dot in Sasha dot? So that's the way I access the struct element, the member of the struct. Oh, thank you, Tom. Thanks for answering that already. Yep, good. Okay, so in here, what I'm doing is I'm checking for those boundaries. I'm seeing if Sasha at position row, and remember, right now, for example, I'm standing over here. So I'm meant to be over here at 9, 9, okay, so I'm over here right now. So if my position, if I've said go up or go down, but if my position row is less than 0, okay, then I'm going to return it back to 0. So if my row is less than 0, so if I was standing at row 0 and I got asked to move up, that's what's going to happen. So I'm going to move it back to 0. So I'm not going to move myself. I'm just going to stay at the 0. Okay, else if my column is less than 0, that means I'm standing somewhere over here in this column, okay, and I'm being asked to move to the left, okay. So if I'm standing in column 0 here and being asked to move to the left, I'm going to come off the board. So I'm saying, no, actually just stay there. Don't move. Okay, great. Else if my row is greater than the number of rows or equal to, so it's greater than or equal to 10. So that means if I'm standing in row 9, so I'm standing over here and I want to go down, that means my row is going to increase to 10. Okay, so that's going to, I'm going to stay at the same way, and then the same thing for columns. So if I'm standing on that side in the column 9 and I want to go to the right, that's going to increase my column to 10, which doesn't exist in my array. So I want to keep staying at column 9. And remember that this is equal to 10, so that's why I've got the greater than or equals to here, and that's why also I'm subtracting 1 from it, because it's going to place me in the last index of my array, which is 9. Okay. And yes, you can absolutely do this in a lot more simple way, okay? But I wanted to show you exactly what's happening step by step. So you can definitely make this a lot more efficient than what it is now. All right, then I call out to my function to print out this section. So I'll go back down over here and I'll print out the row, the grid again. Okay, fantastic. I'll return back to here after I've printed. And inside my while loop, I'll say, okay, where would you like to go now? Because I'm going to take the next command, okay? And someone said, yeah, so why am I writing if it's not greater than 10? Yeah, it's to avoid those magic numbers. And the reason for that is, what if tomorrow I decide I'm going to explore and I'm going to make my grid 15 by 15? And what that means is I only have one place in which I need to change it, okay? And that will be in my hash defines. I could make this a 15 by 15, and that's it. It would carry across the whole thing, okay? So it'll be really, really neat, a really neat, much neater way to do it. Because if you think about it, when you have 1,000 lines of codes, 2,000 lines of codes, looking for, instances of 10 or 9 can get very tedious and might not necessarily relate. And which is why we have these hash defines, so we don't have to do that. Okay, excellent. Let's I think that's this whole piece of code really. So we've done it. Yeah? How does everyone feel? Tom, could you just pop a poll on YouTube? How is everyone feeling about this 2D section now, 2D arrays? Because I know that people really wanted me to go through it in more detail to understand what on earth this code is doing. And it's going to be relevant for your assignment. Okay, there's some people are saying too fast. So maybe Tom will just pop a poll on. He's doing it. No, I know he's doing it. I'm just commenting out what you're doing. So he's going to pop up a poll. So please let me know if we are too fast, too slow, if you understand what this code is doing. If not, I would love to know which lines are confusing you or what is confusing it.
Technical difficulties.
Oh no, I've lost internet. We're like in a dungeon. It's not a dungeon, but it feels like a dungeon. We're like in this soundproof room. Yeah, so a lot of this code will be really kind of, these ideas are very relevant for assignment 1, definitely for stage 1 of assignment 1. And so if you draw it out, you're really going to be able to go through it line by line, okay? Draw it out. You'll see what each line is doing. You'll understand how you can transfer that knowledge to assignment 1. The section part is, I called that my array, my 2-dimensional array, I called it a section. So when I declared here, where is it? Here we go. Int section, that's what I called my 2-dimensional array. It is very close to stage 1. This is correct. This is why I want you to, yeah. No, look, this code did not have to reach 100 lines, right? There's a lot of comments in it. Also, this is not particularly efficient, just doing if statements all the time. You can do it better. You don't have to do it better. And I know a lot of you are saying, oh, how many lines should assignment 1 have? Oh no, it's going to have it's actually a lot easier to write more lines of code than it is to write less lines of code. So, I used to get, well, Tom is just the master of verbal diarrhea when he writes documents. So what is section? clearly, if 3 people have asked this, I've chosen a terrible variable name. Apologies. What it means is that is my grid. That is my 2-dimensional array here. It's called section. That's my grid that I've drawn here. This thing here is called a section. Yeah, do not have this many comments in your code, please. This is not good code. This is not good comments in a code. This is a lot of stuff. And also, when you finish, let's get rid of the to-dos. Exactly like you should in your assignment. Get rid of the to-dos once you've done something. I do, indeed. I need to call it a grid or something else. It is a terrible way to do it, what I've done. Okay, so someone wants me to just go over... I can't see it. Wait, here we go. Got it. Okay. All right, so you want me to go over the boundaries again? Sure. Let's go quickly over the boundaries again. No problem. Where are we? Okay, so let's look here. Check for the boundaries of the I'm gonna wipe this out, and I'm gonna give you a situation where I need to use it. Okay. All right, let's say I am standing over here. Okay, that's where I'm standing, S. Okay, and when I scanned in a command, so when I scanned in my command up the top here, I scanned in a down arrow. Okay, so if I'm standing at this point over here, that means that my location right now is at 9, at 9, 4. Okay, that's my current location if I'm standing over here. If my current location is over here, and I said I would like to go downwards, that means my row has increased by 1. So that means that this over here has actually gone to be 10, 4. Okay, now 10, 4 is outside of my grid. So when I go to check my boundary conditions in this piece of code, what I'm doing is I'm saying, okay, is my row, so, and I am inside the row, so is my row less than 0? No, it's not. Okay, no, I didn't mean to, sorry. Okay, it's not, so I'm not going to do anything there. Okay, I'm going to check this statement now. Is my column less than 0? No, it's not. My column is 4. We're all okay, so I'm not going inside this if statement. Is my row greater than or equal to n rows, which is 10? Yes, it is. It is equal to 10. So this if statement is my relevant if statement that I'm going to move inside of. And I'm going to say, in that case, please take that position row and change it to n rows minus 1. So please change it to 10 minus 1 is equal to 9. So that means what I've done is I've changed it back to 9, 4. So that means I'm not going to move. I'm just going to keep standing there when it's going to happen. Okay? How is that? I think, who asked that? Could you please let me know if that was all right, if that makes more sense? What will happen if this code runs? Magic. No, not magic. Okay, let me show you what happens if we run it. Okay. Oh, that I don't want to remove the zeros in case I need to explain something else with the zeros. So I'm going to keep the zeros there for a second. Looks pretty bad. Okay, no, that's also not what I wanted to do. Here we go. Okay, DCC. Okay, excellent. All right, so I've got a grid, the first time grid. So as we said, the person is standing at 9, 9. Okay, so where would I like to go? I don't know. Let's go up. I'll do up, press enter, and it's going to move me up by 1, and it's going to leave me a 1, you know, where I've already been. Okay, let's say I'm going to go up again. So it's going to move up again, and now there's 2 1s. Okay, I'm going to move to the left. It's going to move me 1 over, and then it's going to leave a 1 there. Okay, should we go down? Let's try to get off this board. Okay, I'll go down, down, And notice if I press down again, what I should be doing is dropping off this grid, but instead I don't do anything. I just stay on the grid. It won't make a difference. It just keeps returning me to the boundary. Okay? Yeah. Yeah, so it's like I've moved, my row did increase to 10, but I checked, is it 10? And if it is, I don't want to, and you can do it all in one, right? You don't have to do it like a separate condition. You can do it all in one check. But I thought for this particular exercise, it would be useful to separate it out so you can see exactly what's going on for each time. Okay, excellent. Someone said we didn't need to, I don't know. Tom, you just write on the board whatever I need to answer. I've lost the track of the chat. Okay, how is that? Is that there's still a few people a little confused. So maybe you will need to like either pop in the chat now what in particular you think is you're finding confusing, and then also to re-watch that part of the lecture. So I'll just give it 30 seconds if people want to tell me what they're confused by, because there's also a 10-second delay, so it's actually 20 seconds. I should fill it with elevator music.
Lo-fi.
Yeah. Is it possible to make the arrow keys on the keyboard the commands for moving? Oh, that's a nice question. And let me just press Control D. Okay, the reason we're doing them these weird things, well, not weird things, just, why does it have to be so painful? Come on, please. I think Tom's writing something for it as well. Is that what you're answering? Yeah. And I'm going to bring up the ASCII table. Okay, so what happens is that, okay, we're really using characters because it's easy to scan in a character because we've learned how to scan in a character. It's an ASCII value, so it makes it really easy to do. If you want to use the arrows, yes, you can do it, but it's a little bit more difficult. It was the same thing as if you saw in assignment 1, we're using some colors as well, which is pretty neat, but it requires some things that are not, we haven't quite done it yet. So you can do it. You can really do a lot of things, but it's not, it just goes into the too hard basket for now. For now, we want you to scan in a character because we want you to learn how to scan in characters. The other stuff is like the bells and whistles. And we don't care about bells and whistles right now. We want just the basics right now. And someone asked, why would there be a delay? There's a delay in what you see and what you get. In case I swear, I reckon. No. Okay, so, and someone's asked something else that I saw that I thought that's a good question. And Beef where was it?
Question.
Hey?
Beef jerky's question.
Yes, it was. Well done. Thank you. Okay, what code did you change to make the ones appear where S has previously been? Okay, so I've gone through, I've printed it out, and this is the part where I've used to change where I've been already. So I said that I would like to have whatever, so before I change my position again, right? Before my position is changed again, I wanted to see where is it that I'm standing. I'm going to make it a 1 instead of a 0. So that's what that's where it was done. Yeah. Should I do a comment in there if you can look at, so if you look at it, this next line changes the grid element to 1 where I have been already. Yeah. Okay, excellent. Good, very good. Okay. All right, that looks good, I think. I think we're kind of okay. Still a few people confused. Can we end the poll and start it again? Sorry, Tom. Thank you. Tom's just going to end the poll and start it again. I really want everyone to get this because I really want everyone to do well in assignment 1 or to do the stage 1 at least. Are arrays only ever used if we want to print out a grid? Well, you want two-dimensional arrays used. They're used for other things as well. We're just using it to show you with a grid because that's the easiest thing to imagine that you understand and that you can see really well. So it's like if you print out a grid, you can see a visual representation of what that array, the two-dimensional array, is doing. Go, Tom. Tom always types really fast and his keyboard is really loud and it's very soothing. Well, I find it soothing, but it's really weird. I know what we should do. One of our pre-entry music should just be keyboards going. Explanation.
Typing too fast for good spelling.
You've seen how I type. It's all good. You still don't get the point of EOF, okay? Okay, great. We're moving a lot of people into the not confused section. I like where this is going. Okay, so the point of end of file, okay, is sometimes to signal a different way to end my input, okay? Because if I want to enter in, you know, infinity, no, not infinity. No one ever wants to enter infinity numbers. That would be ridiculous. Unless you had like a lot of spare time, no hobbies. Maybe you would want to do, but how would you get to infinity? All right, I'm nerd swiping myself. Okay, stop. No infinity entries. So if you wanted to enter, you know, you don't know how many things you want to enter. When are you going to end that while loop? Okay, you really want to know, you know, when to stop. And Control D guarantees that you're going to stop at some stage when Control D is pressed. Okay, so what it means is you are giving the user a way to stop entering things into the system. So you will keep asking them until they press a Control D. So EOF is this wonderful thing. It's a special thing that allows you to control the amount of input without knowing how many times they'll enter something in. Oh, that's a good idea. YouTube Shorts for some of the parts of the lecture. That's a really nice idea. I like that. Tom's noting it down. I don't know if he is, but I've just told him. He's noting it down. There we go. Thank you, Tom. Okay, excellent. All right, well, what I think we're going to do now, so that we start pointers on a really positive note, on a really positive vibe, what I want to do, can you show us how you would do it without having scanf in the condition of the while loop? Yeah, I just have another, I mean, it's not as efficient, but I'd really like have int scanf, struggle town, return. Then it will return something for me. So I'd have that up there. So scanf, nope, scanf, yeah. Really struggling typing today. Here we go. Okay, so I'd scan something in, yeah? And then here, instead of checking for the condition, I'll check that whatever it returned is not equal to end of file. That's really what I would do. All right, awesome. Okay, so I think we'll take a 5-minute break now, okay? And then what we'll do is we will start pointers after that. I want everyone to prepare themselves, you know, to get a drink and to get some snacks to really, you know, just feel the full pointer vibe. All right, so let's do, where am I? I'm going to erase this now. So that's it. I can't go back to the grid now. No, I can. I can if someone needs me to. Okay, that's good. All right, let's do a... All right, let me do that, and I'll carry this out here. Okay, and then we're going to have a 5-minute break. All right, welcome back. It's pointer time. Okay, you might have heard from people, I don't know what kind of people, but that pointers are very difficult and they don't really make any sense. So I think they make sense when you're like, yeah, that's simple enough when you're talking about pointers. But then when you actually try to use them, they can be quite hard. Also, we haven't really come to this like amazing need for pointers in this course. Like, you can do everything that you're doing without knowing pointers. So thank you, Tom. Tom wanted to film me. I wasn't just chanting. I was like doing a whole like, pointers! Let's do it! We can do it! And so, yeah, so pointers are like, what's a really polite way of saying it? They can do some really funky things in your code. I think that's a polite way of saying it. Yeah. Okay, so I don't want you to worry about it as well, because you're going to do pointers now. We're going to play around a little bit with them, okay? And we're going to see, okay, this is a pointer, this is what it does. But you will really see the point of them. Oh my God, I can't believe I just said that. Oh God. You will really, I can't. It's too much for a Friday. You will see the point to them. Actually, in like a week, next week, you'll really be seeing a good point to them. Oh my gosh, for someone that couldn't deal with the red dot, I've just placed another red dot randomly. Here we go, red dot gone. Don't worry, I gotcha. I didn't mean to make the pun, it was terrible. Oh my gosh, I was like... Okay. I love it. Yeah, it's true. Tom is the pun king. So if you ever see like puns, you'll be like, yeah, that's Tom for sure. And bad jokes. Well, dad jokes. Bad jokes. Equals, not sure. All right. So let's talk about what a pointer is, okay? Oh, and what's a pointer? Why do we have a pointer? What on earth is a pointer? Everyone's like, what is a pointer? Okay. Here we go. A pointer is just another variable. Nothing to stress about. All it is a variable, but it stores a very special value. It doesn't store, an int or a double it stores a memory address of a variable. Tom's a dad. No, Tom's not a dad. He's ready, I think, with the types of jokes that he comes up with sometimes. So, pointers, they're just another variable. They store a memory address of a variable. That is all there is to them, okay? It's how you play around with them and what it gives you the power to do when you have a memory address, right? Think about it. You've got a memory address of something. So what that means is you can modify information at that memory address. You can you can do a whole bunch of things at a specific memory address, and you can really stuff up that piece of memory address, or you can try and go to a memory address that doesn't exist, so what happens then? So it's very powerful. So we're giving you some pretty powerful stuff here when you start to play around with pointers. Now, pointers are quite important for a few reasons. We'll talk about it in a second. So far, you haven't really done anything that needs a pointer, so it might not be obvious why we're doing pointers. It's coming, don't worry. You will see why you need pointers. So a pointer, very powerful, means you can modify things at the source because you have the memory address of something. But to declare a pointer, you specify what type the pointer points to with a with a star. Okay, so you say to declare it, type that it's pointing to. So if I've got one that's an int, okay, it's pointing to a memory address that holds an int. I'll say an int here. Then I'll do this beautiful star here, and then I'll just give it a name of a variable. I don't know why that has a space. That shouldn't have a space. Oh my gosh, that's going to annoy me now. So for example, if your pointer points to an int, you would declare it as saying int asterisks. Nope, that was not correct. Asterisk pointer, which is the name of the pointer. Okay. So that is an example of it. So why do we need pointers, really? You know, because you really need to, why on earth do we have? Okay, so pointers solve two very common problems. One of them, I said to you, we pass some inputs into a function and it makes a copy of that variable. And the more copying that you do, the less efficient your function becomes, obviously, because you're doing all this copying and everything is creating memory, copying. Okay, but pointers allow us to kind of bypass that because they allow us to share information much easier between sections of code without all that copying happening. Also, pointers allow us to play with more complex data structures such as linked lists. Now here I said they're coming in week 7, but today I've decided they're coming in week 5. And everyone has agreed with me, so linked lists are coming in week 5. And the reason they're coming in week 5 is because I want you to have more time to do your assignment to, so you can familiarize yourself with things. So things are going to have a little shift as well. So what happens is that you need to use pointers to be able to use these more complex data structures because they need to know memory addresses to be able to do anything, okay? So it's coming and it will really help with understanding what pointers are and how to use them as well. So I thought that could be nice as well because linking them together closer to each other will also give you a better way to explore pointers too. Okay, so let's have a look at some code and I'll talk about the 3 things that we want to do, 3 parts to a pointer. And we also have a short video about pointers that we will make available to you as well. So you can watch this short focused video and get a real feel for pointers as well. Okay, so first of all, we declare a pointer with an asterisk. I did it. I said it. It was perfect. I can't say it again. I don't want to ruin it now. So this is where you will specify what type the pointer points to. Okay, so for example here, I've specified a pointer that points to an int, okay? And I've said that it's a pointer because it's got a star here. Now something that I do as well is I usually, when I name my pointers, I will give them a PTR at the back so that I know that it's a pointer. That's you don't have to do that. That's just how I name my variables. We've all seen I also do sometimes bad names for variables. Hello section. That was clearly a terrible name for a variable. But it made sense in my head at some ungodly hour of the night. Okay, and then the second part to a pointer is, yes, pointers do happen to explain why you need the ampersand in the scanf. I am so excited. Yes, it does. Finally, you will have a reason instead of just trusting me. So yeah, we're about to get to it. Don't worry, in literally 2 seconds. Okay, then you initialize a pointer. Okay, so you assign a value to a pointer by assigning the address of a variable. And remember to give the address, and this is what you've been doing in scanf this whole time. So in fact, you've kind of been using parts of pointers and all the fun stuff already for 4 weeks. So you're super ready. So what you're doing here is, because it's a pointer, it holds a memory address. And the way to give a memory address is to put this ampersand in front of the variable. Okay, and I'll draw it for you in 2 seconds. So the ampersand says I want to give the address of that variable, and that's why, because you scan into a memory address. Okay, and then the third part to a pointer is it's called dereferencing. Okay, and what that means is when you use a star next to that pointer name, okay, what that means is go to the address inside this variable and find out what is at that address. So you are literally dereferencing it. So you're taking what's at that memory address, you're heading to that memory address, what is stored in there. Yep, I'm going to take that number and that's what is going to be in there. So let's have a look at it visually, okay? All right, so let's say we have this very primitive, very small stack, okay? So it's let's say this is my section of memory, okay? Now, these are just random memory addresses. They don't mean anything. They're just something I've made up, for poops and giggles. So there we go. So they mean nothing, okay? Absolutely nothing. So let's say I have this piece of code, okay? Now this piece of this piece of course, I'm having problems speaking today. Oh my goodness. It's a Friday afternoon. This week will end, I promise. You've got not much longer to go with this lecture. All right, so we've got a normal variable, okay? You all know what's going on, okay? So we've got a variable called box. It is of type int, and it's got value 6 in it. So when you do that, it's just going to take a random piece of memory, and it's going to assign that variable in that piece of memory, okay? So now I'm going to declare a pointer, and I'm going to assign the address of that. Okay, so my pointer is going to point to a type int. The star here says it's a pointer. I've called it a box pointer. And what I've done is I've used the ampersand symbol here to assign the address of. So what it means that inside my box pointer, so this variable here, now stores the address of whatever the box is. So box was stored in here. This is the address of it. And that's what is now stored inside my variable. Okay, so so there we have it. So that's a very basic, visual of what it's doing. So let me erase that, and we're gonna just do it. Hang on. Whoop, whoop. Here we go. Here we go. Okay. All right. So let's have a look here. Okay. So let's then say I want to print out the value of this, and I'm going to introduce you to a new thing, a %p. That's going to be super exciting. Which just really means pointer, print out the address of. Okay, so the value of the variable box is located at address p, okay? This %p prints out a pointer address. So what it means is if I have the pointer variable in here, that's what stores the address. So it's going to print out this value here, okay? And then I'm going to say whatever's at that address, please print it out as well. And that's when I'll use the star and say, okay, can you dereference this pointer? What that means when I dereference this pointer is I'll say, what is stored at this address? Oh, at this address we have a 6. So that's what I'm going to print out there. So let's see it as a piece of code so that you can see how it actually behaves in a piece of code, and so you get a feel for how to write it as well. Nope. Look, I've gone out of the bounds. I've gone outside the boundary of the screen. Hold up. Why is it so long? Here we go. Oh, now my terminal. I do love to have a chat with myself. Clearly having a good chat here. I can do this. Here we go. Okay. Okay, here we go. Nope. There we go. All right. So let's have a look. Let's have a look at what it actually produces out for us as well. Okay. Okay, so someone's asked, how could we know the box pointer is that and not in blah, blah, blah? Because I've signed it the address of box. That's how. Okay. But it is also really random. I don't know where box is going to go into. Wherever I just put it on the bottom, it could go in the middle, it could go on the side, it could go up the top. It's not really, it assigns it to a piece in memory, and then I have a pointer to that piece of memory. The whole thing is that it's random in memory. Okay, so let's have a look. So we have a variable that is called box. It's of type int, and it's equal to 6. So now we're going to declare a pointer and point it to the address of the box. So to declare a pointer, and I know that I want to point it at the box. The box is of type int. So my pointer is going to be of type int because that's what type it is pointing to. And I'm going to say I want a pointer, which means I want an asterisk. And then it's going to be, I'm going to call it box pointer. And I want to initialize it. Oh, I haven't initialized it. No, I have. It doesn't make sense what I've said there. Okay, pointing at the address of the box. Okay, so let's do it. So then I'll point it to the address. To get the address off, I'm going to use the ampersand symbol. Okay, so the ampersand symbol here is going to have, that's going to tell me the address, and then the address of the box. And then I've got a pointer. Let's see how this %p looks like. So let's say I want to have the value of the variable box located at address %p. Now my address is stored inside my pointer, which means the variable is called box PTR. That's going to give me my actual pointer. And then the value is going to be %d. Okay, so what that means is I want the actual value that is stored at the memory address that the pointer is pointing to. So what that means is I want to be able to go to this address and dereference it. So really, this is my actual pointer here. So to dereference something, I put a star and then whatever the pointer name, that will dereference it for me. All right, let's have a look for it to run so you can see it in action. And then we'll talk about some dangerous things you can do with the pointers. Well, just one dangerous thing. Well, just one today. One dangerous thing at a time. Okay. Let's run it. Okay. So it's saying the value of the variable box located at address blah is equal to 6. So we know that the address is random. If I run it again, it might give me a different address. In fact, it will, right? Because it compiles and it does it in there. So what does dereferencing actually mean? Excellent question. Let me show you again what dereferencing means. What it means is I want the value that is stored by the pointer. So what it means is I want to know what the value is at the address inside that pointer. So if I have this pointer, go to the address in this variable and tell me what is actually stored at that address. Okay, so go to where you need to go and get me what is stored in there. That's a good, yep. There we go. Or I just switched it off by accident. Oh, it's here. There we go. Floating. Okay, so and is what says the address of that variable, and then I've got the star, which means take me to that address. Okay, and this is my declaration of a pointer. So I've got a pointer, I'll assign an address to it, and if I want to know what is at that address, I dereference it. So I say star and then pointer. Yeah, you can do that. You can print out, yeah, you can. You can absolutely do that. What is the use of knowing the address? Does it actually have any meaning to us? It will, okay? It will. So as I said, right now, you're going to be like, what's the point? I really don't see the point to this. Like, I can do anything I want to do without knowing the address of something, except for scanf. You've already seen that you can't actually do scanf without knowing the address of that. And the reason for that is you created this variable that you're going to scan into. But if you're going to scan into something, you really need to know where to go to be able to scan into it. And that's why we give it the address of that thing, because then we're putting something straight into it. So you'll see next week the huge reason, one of the big things is that knowing memory addresses helps us to use more complex data structures such as linked lists, okay? And that's because linked lists are all really based on taking some memory, using that memory, taking some more, using that more, and they're not. So far, we've learnt about arrays. Arrays are consecutively stored in memory, right? So you don't really have issues accessing things. There are other data structures that are not consecutively located in memory. Just because you know the first one, you don't know where the next one is. You don't know where the next one is. You don't know where the next one is. So this is where you need to know the memory addresses, because you can go on a bit of a scavenger hunt. And ooh, I'm just giving you some little bit of what's coming next week, scavenger hunts for memory addresses. Yeah, so that's right. So Tinny said you printf %p and box. That is going to give you the memory location as well. Absolutely, because and box is a memory location. Okay, so you're printing out that memory location. And so the variable and the pointer works to access both memory and location. So what happens is that I have said that this variable here is the one that stores the address, okay? Now, if I'm storing an address, that means it's a pointer because it's a pointer to an address. So then I will have the star pointer to declare it, and I'll assign the address of box to it. And then it really, inside your pointer is always going to be an address because that's what a pointer is. It stores, it's a variable, but it stores a memory address. Yeah. Yes, so someone said when you pass a variable into function, it only passes its value. So yeah, so we're about to go to functions. It's coming, I promise. So that's one of the other reasons it can be useful to use pointers as well. If you remember, I was saying as well before, one of the reasons for pointers is when you pass things to functions, you make copies of those things and then you modify the copies and then you return something to the function. But the original thing has not changed. So I think I have something here that kind of demonstrates. Yes, I do. Okay. No, but I'm not ready to do functions yet. Stop. No, I'm stopping. And back to this. Okay. We're going to do a few more things. Is there a good reason to use pointers in assignment 1? There is absolutely no good reason to use pointers in assignment 1. In fact, I recommend you don't, because you're going to get stuck on something and it's not going to be that nice. Like, you're not going to have a really fantastic time. So yeah, don't. You'll use pointers in assignment 2, but you'll use pointers in the context of a different data structure. So it will be they'll be a lot easier to use exactly as well. Speaking today. All right. So what I've said then is, don't worry, we're about to go back to Daniel, is that an ironic comment? I'm not sure. Maybe there's, again, I'm sorry, you have to trust me today for more use of pointers next week. So right now you can do everything you've been doing without using pointers, and so you might not see the point to them. Next week you will not be able to do everything without using a pointer, and I'll show you why. So you'll see a really great reason why we need pointers. And we're about to do more of it. Okay, don't worry, we're about to do more pointers. I'm not just moving out. Is there a limit to what we can point to using pointers? Oh gosh, sky's the limit. And I was just about to say, the sky's not the limit. There are some limits. Well, you can do some very funky things, but you're not going to be doing the funky things in COMP1511. Okay, we are being very, very nice. Don't worry, we're only going to do a few different pointers. We're not going to be going crazy. So you can have a pointer to an int, you just have an address of the int. You can have a pointer to a double, in which case you declare it as a double pointer. And again, still the same, you just point it to the address of that variable. You can have a char, and then you'll point it to the address of that as well. So you can do a whole bunch of things, okay, and declare it based on whatever the variable is that you are addressing, whatever that the pointer is going to store the address of, that's the type that the pointer is going to be. Okay, here we go. This is one of the funky things that you can do with a pointer. And it's going to be called a null pointer. And don't worry, I can see a few people are confused. Don't worry, we will recap with a diagram. Don't worry, it's coming. Okay, so there is this thing called a null pointer. Okay, and you will actually use this, right? Because, it's good practice to declare a variable, to initialize a variable. So sometimes when we have a pointer that doesn't have anything in it yet, but I want to create a pointer, to initialize it, I'm going to assign it the value null. Okay, so again, it's a special hash defined thing. Null, usually it's a 0, but don't ever use a 0. Use null, because that's the proper, that's another magic number. Someone said, do we care about the actual pointer number? The actual address stored inside the pointer? No, we don't. We just care about knowing that address or being able to go to it each time. So sometimes we will initialize, no. So that's a very good question. Isn't initializing a variable like char something is equal to blah? No. unless you use the ampersand symbol, you're not storing the memory address of anything, okay? So when you do your normal variable, when you have your char something is equal to blah, you don't actually know where it's sitting in memory. You just have a variable and you know what its name is. You can assign and reassign things to it. But outside of that main function, you will not be able to use that variable. It only lives inside that function as well. And so if I give that variable to another function, it's going to make a copy of it. So that variable is not going to be touched again, which we're going to talk about in a second, okay? So null again is defined inside one of the standard libraries. You don't need to worry about it. All you need to worry about is that when you initialize a pointer that's not yet pointing to anything, you'll say it's equal to null. So you would do something like, you know, let's say it's an int. You could do int star, you know, pointer, and then you'll say it's equal to null, and that's it. And it's kind of, it knows that that means it's not, there we go. It means that it's not really, there's nothing to point it to yet. Now the funky thing happens, okay, is when you forgot to do anything to that pointer and you then try to access this null pointer. And the reason for that is when you try to dereference it. So when you say, okay, let's say I've got, okay, I'm going to bring that back. So let's say I've got an int pointer and I've initialized it to null. Now somewhere down along the code, I've lost the plot, which is, you know, highly likely. And then what happens is that I decide I'm going to print something out and I'm going to use that null pointer. So I'm going to say, okay, I want to know what is the value inside that null pointer. And I'm going to dereference it. So I want to know what the value is, okay? Okay, so the star means that I'm going to dereference it, which means I'm going to say, what is the address stored inside this pointer? Okay, the address is null. Go to this address. Can I go to, can I go to a, my face is just floating in all the wrong places. Can I go to a null? Can I go to a nothing address? What do you reckon? Can I go to a nothing address? What do we think? Have you ever gone to a nothing address? Just like personally, you know, someone gives you, you make a new friend, they give you an address. Can you go inside? Can you go to their house if you don't know where it is? No, you can't. You can. No, you can't. You can't. Yeah, the void. Yeah, you're going to get an error, right? You can't. So the problem occurs when you start dereferencing a null pointer. You're going to get some serious breakage because there is nothing there. There's nothing stored at this address. There's nothing exists there. Okay. And, you know, in fact, it's not a problem. You're going to do this quite a bit in the next few weeks where you will dereference a null pointer. The important thing is to know that this is what has occurred, and somewhere along the line you've lost track, or you've lost a memory address, and it's now nothing. Okay, so it's something that does happen as you write code, and it can happen a lot. But it's a pretty, there's some issues that can happen with that as well, and we will talk more about them as we do these types of things. Okay. Oh, I think I actually included it so that you can see what it does. Maybe. Did I? Yes, I did. Okay. So let's say this is what the error looks like. I wanted you to have a bit of a thing of what the error looks like. Okay. So let's say I've got this piece of code. Okay. And the piece of code is basically starting a pointer, assigning null to it. Okay. And then I'm going to try and access it. So I'm going to say the address of box pointer, which is null, is going to be dereferencing the null pointer. And so you see here, it's going to give you the error, accessing a value via null pointer. You're using a pointer which is null. Common error is accessing, dereferencing it when p is equal to null. So it's going to spit out this type of error at you, and it's not going to like you very much, but at least you will know what it means. Okay. I mean, I said it's compiles then chaos because it does compile, okay, which is the worst thing ever. Because it's not, the code is not wrong itself. It's just when you try and access nothing, you obviously get nothing. There's nothing to be gotten because that memory address is not, there's nothing. If you have 2 or more pointers, can they accidentally point to the same memory address? It depends what you initialize them to, because when you create a pointer, you give it the address that you want it to be pointing to. Yeah. So you want it to be, you can point them to the same address, in fact, but potentially not accidentally. Well, yeah. Is the code engulfed by the void? Yeah. And then it starts burning your hands when you touch the keyboard. Yeah. Okay, let's have a look at one of the other things. We've already done pointers and functions. Okay, so this is what I was saying before. Okay, so this is one of the benefits of pointers, perhaps. Yes, you don't, definitely not on the functions that you've written to this day. You don't really have to use pointers. It can make your solutions more elegant, maybe more efficient as well. Mark, yes, how would you get rid of the null? Yes, it's by assigning something to it. Most often the null is there because you forgot to assign something to it, okay? Okay. All right, so if we pass a pointer into a function instead of a normal variable, it can modify at the direct address of our variable. And that means there's no need to return the result either. So you can you can modify multiple things if needed as well. So what happens is, usually we'll have a variable, okay, and let's say we're going to pass this variable. Let's say I'm going to pass this variable to over here. This is our normal way. So I'm going to pass, this is my cup of coffee. It's really bad. I've passed it in and I've just passed the normal. So it's made a copy of it and I'm going to do something to this variable here. Nothing happens to my original variable, okay? But let's say I give a pointer to this cup. If I give a pointer to this cup and I modify it inside my function, the original variable will also change as well with it, okay? Because I'm changing the value at the memory address, okay? Which means that I'm changing the variable directly as well. Okay, so if you pass it a pointer, that means you can make changes directly and that will also reflect back in the main functions. Okay, can you please share the thing for Slido so that we can see how we're going, or just do a poll in YouTube as well, so that I can see if we can go back, go forward, go sideways, because we're about to do a function. Oh, Jeffrey, great question. Arrays are made with pointers. It's coming. Just wait. Just wait. They're different things, but something is, just wait. Just wait. That is a very good pick, Jeffrey, and just wait for it. I will talk about it. Arrays, they're not pointers, but they decay to, just wait. Before, let me just see that everyone understands here, and then I'll talk a little bit about arrays as well. But that's a really, really good notice that you've noticed that about arrays. Can you change the value of a local variable outside of a function using pointers? Yes. If you're passing that pointer to a different function that's pointing to that local variable, then yeah, it will change inside the function and also wherever you're changing it, because you're changing it at the source. Oh, Tom is so jealous. Array, I think you're jealous, right, Tom? He's so jealous. Do pointers ignore the scope of variables? Not quite. No, they don't. You still live and die within the brackets, but you can modify things in one function and have it also happen in the main as well, as opposed to passing around copies back and forth. Okay, so the scope still stands. It still dies in the brackets, but yeah. Yeah. Wow, Tom. Throwing shade. I love it. Oh, sad face, Tom. Okay, so let's have a look. Pointers and functions. Stop it. Okay, all right. Back. We're back. All right, let's do something where we pass around a pointer in a function. How does that sound? Let's do that. There we go. Very good. All right. So let's okay. So let's have a look. So this program demonstrates. A few people are still a little confused. Don't worry. Don't worry. We will come back to it as well. I will come back to it on Tuesday again for a recap. Okay. The first time you hear of pointers, it's a bit of a what the moment. It gets better in a year. Also, it's going. Oh god. Would we get marked down for using pointers in assignment 1? You wouldn't, but you're opening yourself up to errors that you might not have if you didn't use pointers. Yeah, the assignment can be done without any pointers at all. Okay. Okay, so let's have a look. So we have an int number. And now let's declare a pointer that points to the address of that number. Okay. It's type int asterisk to say it's a pointer. I'm going to point it to the number, so I'm going to call it number pointer. And I'm going to point it to the address of number. Okay. So I'm going to say and number, which now says I have a pointer called number pointer. And that pointer inside it stores the address of number, whatever that is. Okay. I'm going to say enter number to increment, and then I'm going to scan in a number and store it inside the number variable by giving it the address. So it's going to go to this address and it's going to place it inside that address. And then I'm going to say the original number is blah, and that's going to be the number. And now I want to have a function that's going to increment the number by 1. Okay. And really it's going to be like, again, you can do this without doing any of this, right? You don't have to have a special function. You don't have to give it a pointer. You don't have to do these things. But this is a really, really simple way to show you kind of what it's doing. So that's all that I'm trying to do in this particular lecture. I can't concentrate. The chat... You're all being very, very humorous in the chat, and it's going to, I'm just like, I can't hold the laughter. It's inside me, and I'm about to lose the plot here. Okay, so let's call a function. Let's do a function. I'm going to be super creative, although really we've all seen my variable names, which are sometimes pretty average. So let's just call it incrementer. Is that good? Tom's not even listening. He's so busy thinking of what is the next pun that he's going to do. Okay, I'm going to call the function incrementer and I'm going to give it the pointer. Now the pointer is called number pointer. So that's what I'm going to give it. So I'm going to give it number pointer and I'm going to send it on its merry way. And so now I'm going to do my function here. Now because I'm using a pointer, I'm going to be modifying directly at the source. Okay, So if I'm modifying directly at the source, I don't really need to return anything, okay? So if I don't need to return anything, my function is going to be of type void, which means that, it's not going to return anything. Okay, what's going to be the input to it? The input to my function is a pointer. Yeah, so I'm giving it a pointer. And then the name of the function, well, I've already kind of did that. I called it an incrementer, so I kind of have to use that now. Okay, so what do we think then it looks like? Oh gosh, Tiger VNC just quit out. No, that was not right. So what do we think is going to happen there? Oh my God, it's still going. In line 16, do you write number pointer instead of end number because they both represent the address? Ooh, that is such a nice question. Actually, that is really lovely. I really like that question. Oh. I think, so the standard for a scanf function is just to have a variable and then scan into that variable. You wouldn't necessarily, in this case, I have a pointer to that variable, but usually you don't really have a pointer with that sort of situation. But that is such a nice question. Oh my goodness. Okay, let's have a look. What was I doing? I was doing something or other. Yeah, I was doing my function. Okay, so the function output is void. It's called incrementer, and I'm giving it a pointer. What is a pointer? Okay. Excellent. And now all I want to do is I want to take what is inside that pointer and I want to increase it by 1. So what do you reckon? How do you reckon I would do that? What do we reckon? Has everyone just lost me because they're just so busy doing puns?
That is what it seems like. I'm not making any puns though.
Sure about that. Okay, so a few people are saying int number is equal to number plus 1. Okay, that would be the case. That would be the case normally. Okay, but that would just be, that is using a normal variable. However, we have a pointer, so we want to, yeah. So someone's got it in the chat. A few people have got it in the chat. I like it. So then what's... Okay, a few people have got it. A few people have got it. Excellent, excellent, excellent. So what I want to do is I want to go to the address of that pointer. What is the address stored in the pointer? I want to go to it. I want to take the number that's in there and I want to increase it by 1. So what I'm really saying is I want to dereference the pointer. Okay, this means that that is the variable in there. And then I want to add 1 to it. Okay, so what is going on is here I'm saying if I'm dereferencing, I'm going to go to the address stored inside that pointer and take the actual thing out. I'm going to add 1 to it and then I'm going to store it in. And the reason you don't need to return anything is because you're modifying it at the memory address. So when I've modified it here, it's already happened over here. I don't need to return it. Okay, it's already happening. Okay, so that's why I don't need to return a thing, because it's when I modify at the address, I'm modifying at the direct source. I'm not moving around and making copies of things, so that's why I don't need to return. Okay, and that means that I can now print out what's going on. So now the number is now incremented to blah. Notice that I'm just using my I've already I've already modified it. I've already dereferenced it and modified it. So inside this variable is going to be the right number. So let's see it in action. Let's run it. Yeah, Tom's answered a really good question as well. So someone said, can you do dereference a pointer and add to it? You do have to be very careful at it. You don't learn in this course. You can do some pointer arithmetic. Thankfully, we don't do it here. But you can have some mistakes in there as well. So there's some quirky C behavior. There's always quirky C behavior. There is some weird stuff that you can do. And there is some really weird stuff you can do with pointers. Yeah, exactly. Exactly what Tom has said. Okay, what am I doing? Compiling. I'm just super excited about pointers. Don't worry if you're still not across pointers. Don't worry. We will go through them again. I know that the first time you do them, they are just explosion of fun and fireworks of excitement, but we will do them again. What have I forgotten to do? 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 I've forgotten to do one thing. What does that error mean? I've forgotten to do, yay, I forgot to do a prototype. So I really want to have a prototype of this function. Ah! That was a bit high-pitched. Apologies, Tom. And save. And let's try it again. Let's run it. Yay! Much better. I forgot what I've... Oh, God. I forgot what I called it. Pointer functions. Okay, so if we do pointer functions now... and let's say we've got number 5. The original number is 5. The number is now incremented to 6. So what has happened here and what we demonstrated with this piece of code is that even though I didn't pass my actual variable, it didn't make a copy in the function of the variable, but I gave it the memory address. I gave it the memory address of my variable and it modified it at the source. So it added 1 to it, and then that's what my new variable is now, okay? So this is one of the reasons we use it in functions, is that you can modify things directly at the source. You're not doing as much copying, so it can be a little bit more efficient as well. Okay. Aha, yes, Jack, you asked a very good question. So I don't want to use the terms call by value, call by reference. You're going to hear it a lot, but actually I'm still making a copy. It's just that copy is a memory address. And so what that means is I can modify directly at that memory address. Yeah. Okay, let's look at maybe one more thing. Okay, let's look at this array business. Okay, let's look at this array business. All right. So arrays and pointers. Okay, and someone asked a really good question beforehand, and I was like, no, just wait, it's coming. Arrays and pointers, they're not the same. Okay, array is not a pointer. They're two different things. But an array name is a constant pointer to the array. So you're all just going, she's crazy. Like, this is all too much. You might have heard someone say, maybe one of your tutors, say that the array decays to a pointer to the first element of the array. Okay, what that means is that, and you saw when you give it the first memory, so when you give it the name of the array, what passes is the first thing of that array, the first memory address. Now, if you recall, if you have an array, okay, let's say I have this array here, and the memory address here is 1, this is going to be 2, this is going to be 3, this is going to be 4. So the thing about an array is that it's stored consecutively inside memory, okay? So really all I need to know is this, and I know the rest of it because I also know the size of the array, because we've said we have to give the size of the array. So usually when we pass it to a function, we'll also pass a size for it, and you'll see it. We'll do more examples on it next week. So if we're going to do just a little piece of code so that you see this in action, okay, then maybe, where is my, here. Okay, a little piece of code. and it's going to be pointer array.c. Here we go. Okay. All right, so I just want to show you, okay? So you don't even have to trust me, okay? You can just have to trust the computer. Okay, I've got an int array, and I've said, okay, its size is 4, and I've assigned all zeros to it. I've initialized it with all zeros. All right, so what am I going to do? I'm going to loop through the array and print out the address of each of the elements of the array. Okay, well, we know how to do that, don't we? I've got an int I is equal to 0 to start with. I'm going to have a while loop whilst I is less than 4. I want to print out the memory address. So printf, oops, and let's say the memory address of array at index whatever it is, okay, is, and then I'm going to print out the memory address here. New line, okay. So I want to have an I for my counter, which will say which index it is, and the memory address is going to be the memory address at that time. So let's and array. So remember, we access a memory address by putting that ampersand. Okay, so this will allow me to see what's going on, and then I'm going to increment my counter. So all that this will do is this will just print out the memory addresses of every element in my array, so you can see that they're in order as well. And now to show you that I'm not fibbing you this time, I'm not lying, I'm going to print out, to finish off, I'm going to print out the memory address of the array is, and I'm going to do a %p here. And I'm going to give it just the name of the array to show you that the first, when you give the name of the array, it just decays down to that first memory address. Okay, and let's return 0. All right, let's run it so that you can see it in DCC pointer array dot c o pointer array. Okay, excellent. All right, so now let's have a look what's going on. So it's giving the memory address at index 0 is this. Memory address at the next one is 44. So see, it's increasing by 4 bytes. Okay, and the reason for that is because each int is 4 bytes, so it's increasing by 4 bytes each time. The next one's at 48, the next one's at 4c. And now when I say the memory address of the array, notice that it's exactly the same memory address as the array at index 0. Okay, so the reason I didn't put an AND for the array on line 20, that is a very good question, is because I wanted to show you why it works when you pass an array into a function. Okay, so if you remember, when you're passing an array to a function, you say whatever that function name is, and you just give it the array. Like, so you say, what's my function? And then you say array. And I think Jeffrey noticed that actually the array was modifying already. You don't need to pass it back and forth. And the reason for that is because when you're passing this to a function, what you're actually giving it is that first address. So you're letting it know where to start the array. And if you remember, the array is consecutively stored in memory. So usually you'll see we'll also give it a size so that it knows where it's finishing. Okay. And that's why you don't need to give the AND, because the array name, that's what the point, it decays down to that first address basically. And that's why you can pass around an array with just the name of the array, because it gives the first element of the array. All right, how are we feeling? Tom? Thank you, Tom. Tom's reading my mind now. Yeah. So it's like it, yeah, so memory, yeah, the memory's in hexadecimal, and the name of the array, it decays down to be that first address. I know it sort of makes sense. It is quirky. I do understand. Don't understand the decay thing. Don't worry about understanding the terms decay. I mean, I think it takes a bit to understand what the term decay means in computing. I've just done it in case you've ever heard that term. I think everyone's brain is probably cooked right now. A lot of people are a little bit confused. I feel like that is like the pointers thing. This is why I was chanting pointers, because don't worry, this is what always happens as well, okay? So usually, Alex, where is the size of the array stored? Great question. Usually you'll see when we will have array functions, we'll pass it the array, and we will also pass it the size of the array. So what that means then is you're giving it the address of where it first starts, but you're also giving it, how long it is, that array. You still don't understand why the whole array has the same address as an array. Okay, so the whole array, so this is like, it's a constant pointer type, basically, the name of the array. So the way, and this is just trying to think if it's specific to C, who else does it. But I'm having a very... Who else does it? So basically, you don't have to. It's not like this is just what happens, right? This is how it works in this particular instance. So the name of the array it decays down to a pointer to the first address of that array. So you don't need to store every single memory address, because if you have the first one and you have the size of the array, you have them all. And we'll go over it more in a tutorial and a lab where there's more time to go into more details about it. But no, when you call a function, you would do like something like you give it array and then you'll give it a size, like you'll give it an int size as well, right? So you'll actually give it, so that means you're giving it the address of the first element of the array and you're giving it the size of the array. Yeah. It's not like, this is what I mean, like there's other languages as well where the syntax is different. The structure of the array is the same, but the syntax is different, how you do and how you work with things. Don't worry, strings, you can have strings next week. It's my gift to you because you now have arrays. So now you can have, and now you've got pointers. Next week, strings. Yeah. What is the array? Oh, it was just to demonstrate how you call a function with an array. Joe, it wasn't anything. It wasn't a part of the code. I should have done it in a comment. Yeah. All right. What a way to finish. To make you feel better, this is how a lecture on pointers always finishes. With everyone going, what was that? What was that? Don't worry, it will become a lot more obvious what's going on, okay? Stop. Tom is just looking at me, waiting for me to read his comment. There is so many help sessions happening next week. It is just going to be help session central. Don't worry, you don't need to use pointers in your assignment 1. Okay, it's all okay. And someone's done a slide. Love it. Okay, and someone's asked a question as well. I missed it. It was somewhere in the chat. I really missed it. But it was like, I need to answer it. If you want to pass arrays into a function, you'd give it the array name, because that gives it the first element of the array, and you would give it the size of the array, because that's all it needs to know. No, don't ever feel like that. Don't ever feel, Jeffrey, no. You don't ever want to feel like no. Pointers are what you said in there. I can't repeat it, otherwise I'll be cancelled. All right. I hope everyone has a wonderful weekend, okay? Enjoy. I wanted to do pointers today so that you can think about them a little bit over the weekend, so you can have a really great weekend thinking about pointers. Oh, I'm making myself laugh over that. Enjoy your weekend thinking about pointers. I wanted you to be able to reflect and just to really kind of like just play around with the really simple things, okay, that we've kind of had for pointers, because next week you'll see more of a point for them. So have a really fun weekend. If you have any feedback, please let us know. And I look forward to seeing you on Tuesday. Thanks everyone so much for tuning in on a Friday night. It's always a struggle, I know, but go and enjoy yourselves. The sun's out. So, yep. Bye.